So, this video is to summarize what we were talking about yesterday. Yesterday we really had a very terrible network, and it really disturbed our class, and then I wasn't able to finish up this. And like I promised you guys that said I was going to do a pre-recorded video to finish up the explanation, right? So I'm going to do a little bit recap, and then we'll continue from there. Basically, we talked about front end yesterday. We were able to understand what a front end is, and then a back end, right? Yesterday. So we talked about front end being an interface where a user can interact with the application, either a website, landing page, a mobile application, a desktop application, like the one we are using now, this Figma file, like the one we're using here now. So this is basically a front end. So everything happening here is within the reach of the user. So the user doesn't see the back end, doesn't know whatever is happening on the back end. Then I talked about back end being where the core business model and logic happens, business model and business logic of the application happens on the back end, right? Basically, mostly what's on the back end are usually the database, security measures to make sure people don't hack into the system, and what's next, like all of this that has to do with it. Yeah. So now I talked about APIs. I said API is a bridge that allows communication between the front end and the back end. Let's say you're having phone call, you're calling a friend. So now the ability for you to call the friend and then hear the friend's voice on the phone, and then the friend hears your voice, and then you guys can exchange conversation. It's the same protocol, it's the same thing, like server talking to the back end, server talking to the front end, and the front end talking to the back end, right? I used the illustration of hotspot and Wi-Fi. I also used the illustration of Zenda to explain. Now moving forward, we talked about, I said there are four pillars. If we're diving into web development, there are a couple of pillars that we need to look into. Browser, search engine, protocols, right, and the programming languages, right? Now, then that's what we talked about. I said browser is an application that allows us access to the internet. While the search engine is an application that filters to the internet to give us desired results, right? Now we talked about protocols, and I listed a couple of protocols here, and I gave you guys an assignment to write down 20 protocols and what they are used for. Right, that was assignment number one. So I'm still going to drop second assignment, right, and then a couple of other resources for you to go through. Now, thirdly, I talked about I was explaining how the search engine is able to so we started going back from this protocol, because I started with protocol, and I came back to search engine to show you how search engine actually finds the website, right? I said on a normal level, right, on a regular basics, when you type www.gmail.com or google.com, basically this is what you're going to be typing on a web browser. And then your web browser, there's what we call, I talked about DNS server. So let me put a note on that too. DNS server. So I guess it's this one that I wanted to use to show DNS server. So DNS servers, right? Talked about DNS servers. I said a DNS server is a computer on the internet that has a record of all the database of all the website and the location where to find the servers to find them. Since the internet, since like we have multiple servers on the internet, multiple computers hosting people's websites, so we have more than 1 billion servers on the internet currently. So if we look at the full meaning of the internet, it's the interconnections of different computer systems located all over the world. If you look at the cobweb, so the cobweb is a good example to really know how the interconnectivity works, right? So each computer is called a node on the internet. So each server is called a node, right? So a node is a computer on the internet that serves as a server, basically. So if I decide tomorrow or today let's say tomorrow, basically, if I decide to host my own server, I can set up my stuff, install the appropriate software to make my system a server, and probably host my website, and then you understand, on my own system, and it's going to be working. And if you type the URL that I'm going to give to you, it's going to basically bring it up, and then spin it up, and everything is going up smoothly, right? But we don't have that energy, we don't have that time, we don't have the power and all of those stuff. Not that we don't have the power, I mean the power in terms of electricity and other component factors that we need to make it up and running. So instead of us trying to, each time you want to build your website, instead of focusing on building a website and then deploying your website for other people to start using, start thinking about how to set up your own server, how to do this and how to do that. So basically, a lot of people started coming up with the server idea that, okay, why not I build, okay, so a couple of people start coming up, okay, I have the infrastructure, I have the money to run maintenance, security, and to put on protocols to make sure that the server are correct and running properly and are available 247 on the internet, right, without interruptions. So just come, pay me this XYZ amount of money and then put your website on my server. Whenever someone wants to access your website, the person can just go through my server and then accept my and then access your website. Basically, so I said DNS server keeps record of all the whole website, the addresses of where each website um, is on the internet or can be found on the internet, basically. So I talked about how this is mapped. I said I think I said protocol, the I think location, protocol, and this I can't even remember the right sequence, but the DNS server contains these numbers on the DNS server contains couple of information. The protocol, I said the protocol, sorry, the port, right? The port, the port, the address, right? Unique address, the server location, and a couple of other informations that it contains, though. So just know that these numbers are not just for fancy. These numbers you're seeing here are not just for fancy. Like this is not correct, basically. But this is an example to show you how DNS. You can look up how DNS numbers look like. DNS and DNS numbers look on the internet. Like you can search it and then you can see examples of them on Google, right? So what basically happens is that. So I'm going to copy this. So a DNS server keeps record of how, where to find all of this website, right? Basically, because since we have millions of websites to deal with, or millions of servers to deal with on the internet, so the search engine doesn't really know where to go to. So what happens is that there are list of popular DNS servers, right, that has record. So what happens is that Google goes to this DNS server and be like, hey DNS server, someone just type in www.google.com. Please go through your database and give me the equivalent, the DNS server for the house address, or let me use the house address here, basically. So the house address of this person. It's like asking somebody on a random on the street, and like you want to go to Lagos and then you're now in Lagos, for example, and then you want to go to somewhere like Ikeja and you don't really know where Ikeja is. You can stop somebody on the road and be like, please, what bus should I take to Ikeja? That's what search engine does. Basically, what search engine does is to go to DNS servers and ask, Alpha, DNS server, someone just typed in google.com, please, where is the address of google.com? DNS server will say, okay, give me a second or give me a minute, right? It takes seconds here. It goes through the record and be like, okay, so anybody that's asking for google.com is actually look at the memory address, look at the address where google.com is. So using this address, the search engine goes to the server, to the particular server, and be like, okay, server, hey server, are this, like, are this let's say this is the server name, this is the current section of the server where what's it called, or the folder, the current folder on the server where this your website is hosted. Like, okay, go to this server. Okay, opens the server. Hey server, please go to this section, give me this website on this port. Right now, what's a port? A port is basically an access point. Let me explain access point. So when you build a house and then you can have your front gate and your back gate, right? So different ports or different gates represent different stuff within a server, right? We have 200, port 200. Port 200 actually means like your request is okay and then I can process it and then it will return results. You have 404. I don't know if you've searched for something on your website and then they bring out a 404, like something with 404. 404 means not found. right? So these are different codes. So different port has different meaning, right? Basically. So now let me list a couple of them here. I guess let me list a couple of them here. Different ports. Okay, let me use this. So basically, we have a couple of ports on the internet. So number one, we have 80, right? We have 300, 3,000. Mostly 3,000 are used for local host, right? We have um 404. 404 is error, not found. We have 200. 200 means it's working. 401 means internal server error, right? All of these things have different ports. So a port is basically it's basically a gate. So which gate? Where am I going to access this information from? So which door do I need to enter from, or which door? So what happens is, for example, if you send a request to a server and then the error, it's let's say it doesn't really find, let's say for example, okay, with this DNS code, then I meet the server. Let's say this is Amazon. So popular one of the popular this thing we have is Amazon AWS. Let's say AWS for example. So we have five servers. What's it called? Five main internet servers that power up the world. So we have Google, who has a server, data centers, right? I don't know if I'm trying to I'm going too far on this, but I just want to make a couple of points here, and then I don't really want. So for example, let's say we want to check AWS for example. So now, so now AWS. Oh, I think let me leave this because it's gonna take me further, like more far away from the surface. Like I'm going too deep. I'm going too deep. So just do your research basically. I think I've done basic explanation of how this thing works, right? Okay, so let's just go back to this illustration, what I was saying here. So basically, once the server gets back what's it called, the response from this server, so it sends it back to your own back end, right? Your back end. Now send it back to search engine, and then search engine send it back to the back end, and then the back end is like, okay, alert notifies the front end and said, hey front end, I already have the request. Now the front end sends the request back to the back end. The back end sends the request, sorry, back to the front end through the API, right? The API link, the API. So once it sends it up, now basically let's say our front end, it's we are viewing our front end from a website basically. So which means most of the time, like if we're viewing from a website, so basically it's going to be powered by a browser, on a browser, right? What does the browser do? The browser looks at the sheet. So I talked about different browser having different engines, right? Talk about different browsers having different engines, right? I talked about Chrome having V8 engine, Firefox using Gecko. I talked about which other ones? We have Gecko, a couple of other ones, right? Each browser has their own engine, right? I think these guys are using Firefly, Blink. Sorry, what's it called? What's the name? This default one on Windows. I've forgotten the name of that default one on Windows. Forgotten the name. Windows Explorer. Not Windows Explorer. What's the name of this? I can't even remember again. There's this browser that comes default with Windows. I've forgotten the name though. So I think it uses Firefly, right? Basically. And what happens is that this Firefly now does the main work. This is where our this thing comes in. So there's what we call visualization and screen painting, splitter painting, right? So basically, once it gets in the request, what happens is that um let's say this is the request, and the request doesn't come up just like a request. It comes in form of what's it called, an object. Now what's an object? Basically an object is an abstract sheet that explains different properties and components of a particular object. So if I said, for example, a human being, taking a human being as an object, for example, a human being has different properties like hand, eyes, nose, right? Now that's what we call an object. Like in programming, an object is a sheet that has that gives you an insight of different properties that what's it called a that has sorry different properties that a human being should have, right? So the HTML comes in on a proper the server returns the request based on a property. Now using that property, the V8 engine paints up this page. So each of these places is called it's described in the object, right? Now when we start writing what's it called our JavaScript, we start using object on in depth, right? So basically that's what happens with the V8 engine, and I think I will stop here on that. Now the programming language, we have a couple of programming language that it's supported on the browser. Now we have HTML, we have CSS, we have JavaScript, right? Now these are basic programming languages that are supported on the browser. I think let me keep it down here. Okay, programming language supported on the browser. Right, we have HTML, we have CSS, we have JavaScript, JS. Now the languages are what's it called? These languages are grouped into three, right? So now these four languages are grouped into three. We have on the website we have couple of we have the structural language, right? We have the style, we have the functional. Now let me give you a context here. Now in these three languages, these three stuff you see here that I just mentioned here fall under categories, right? The first category here, the HTML falls under structural language. So structural. So we have other couple of other structural language. We have XML, right, for structuring stuff. We don't just have only HTML. We have HTML. We have this other one. I think there's SML. There's XL. I think XML and HTML are the two popular ones. There are a couple of other ones for structuring, right? Basically, what they do is that they help you structure. They form the basic backbone of any page, right? The same way your bones, right, forms muscles to help every other part to and your body to stand strong, right? Now that's it. So HTML means hypertext for protocol, hypertext markup language. So actually HTML is not a programming language. HTML is a structural language. More on this on the next class, so I'll explain more. Right? Now CSS is for styling. Adding styles, right? Styling. We have CSS, the other ones too. But every other styling, most other styling what's it called? Other styling libraries are built on top of CSS, right? Most of them are built on top of CSS, right? Now CSS has version, the same way HTML has version. We have HTML 1, 2, 3, and then currently we're on HTML 5. I just saw something on Twitter that HTML 6 is available, but basically it's still on HTML. HTML 5 is still what is powering most of the web, so it's CSS 3. So these are the versions that we have now that we're using now. So JavaScript is what adds functionality. That's the only programming language that what's it called that the browser understands. Every other programming language that works on the web or that gives you the hope that you can use it on the web still uses JavaScript in behind the scene, under the hood. Right? I don't know how to explain this more, but like I'm trying as much as possible to make this class very 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 basic and still have you guys understand what I'm saying, right? Because with this like this whole procedure, this whole stuff I've been explaining since yesterday, right? Basically this is the website, like this is the entire web, on a juvie, like on a summary, how the entire web. And then if you can be able to understand this that I'm saying, right, you can pick up anything tomorrow on the webs, and then on the web, and then you are moving, right? And then you can really do a lot with it, right? In as much as like this is an abstract knowledge, right? I know you will not really find people talking about this on the internet, right? But I'm taking out my time to explain this to you, right? I'm taking out my time because I said one of the things I promise is that I'm giving you um my 8 years experience in software engineering in the 6 weeks. Like I'm giving it for free. Like wow, I just want you guys to learn, right? I just want you guys to really learn. I just want you guys to learn and be proud of yourself, right? That you took the first step. You understand, and then you really understood something, right? I know this is getting lengthy already. I don't know how many minutes already that I've gone through on this video recording, but I wanted to make it as minimum as possible. So I'm open to questions. Ask me questions, right? You can watch after watching this video. You can drop your questions, right? I think probably I will create a Google form link. If you have your questions, just drop in your questions on the Google form link, and I will reply. I will reply. Like I'll try as much as possible, as soon as possible to reply. You can drop it on okay. Just drop everything on the WhatsApp group. I'm going to reply as fast as possible as I can, right? So moving forward, so we have JavaScript. JavaScript basically, right, uses V8. Runs on this V8 engine, right? JavaScript is the only language supported on the web. Any other programming language that promises you to work on the web is still using JavaScript under the hood. Because what happens is that, let's say, okay, programming language like Python, Golang, and all of those things are saying you can work on the web. So what they do is that they take up that whatever you've written on that programming language, convert it to JavaScript, and then the V8 engine interprets the JavaScript. Right, interprets the JavaScript and then converts that JavaScript to a C++ programming language before converting it to an assemble programming language. That's how it goes from assemble to zeros and one binary. So now, so currently I don't want to like move down that lane, right? Because it's gonna take us. It's a new topic on its own, right? It's a very massive topic, and I don't know. Maybe let's go. At least I don't know. Even if you don't learn anything on this program, I want you to really learn this one. And I want you to really learn this one. This is computer science, MIT computer science class, right? 80% of Nigerian university will not show you this. I'm showing you. But let me still show you though. So currently, what happens is that good. So I'm still coming to that. So JavaScript basically adds functionality. So currently what we are using is we have different specs of JavaScript. So we have progressions in HTML from HTML1 to HTML2, 3, 4, and then we're now in HTML5 currently. From CSS 0.1 to 1 to 2. Now we are now in 3, right? Now yes, so JavaScript. Every year they release a new version of JavaScript trying to what's it called? Because the whole goal is to make the web faster, and then so you can do couple of stuff on the web, right? Ordinarily before you could not do plenty things on the web. The web, like version 1 of the web, was just basically version 1 of the web was just basically read text. Now this version 2, you can text and get response. You can do media, video, and all of these things. And I'm currently now we are now in version 3 of the web. So VR does blockchain, using blockchain decentralized servers to power up the web. So we're not going to go on that one. So we're focusing on web 2. Right, because you really need to understand how web 2 work. So now this whole stuff I've been explaining since is from web 1. So I'm explaining web 1, now taking it from web 1 down to web 2, right? Now, this is where we are on Web 2. So now, moving forward, so the current version we're going to be learning is going to be EX6. EX6, right? So actually, the real name of JavaScript is not JavaScript, right? JavaScript is the nickname of JavaScript. The actual name of JavaScript is ECMAScript, right? So the JavaScript name came, the nickname JavaScript came up when, um, during the days where when Java was the core stuff, right, to do everything basically, right? So JavaScript, so people started calling it, okay, so people started calling JavaScript the lightweight of Java, because JavaScript at that point, at some point, I think around 1998, is it 1998? I think around 1996. Just that period, 1996, 1990, started powering the whole internet. So they were looking at, so for people to, the storyline for people to start using that programming language, right? So they started calling it, what's it called, JavaScript. So that's Java, then the script. But the actual name for JavaScript is ECMAScript, right? ECMAS. So that's where you get this EX. EX means ECMA. E is ECMAC, then script EX. So version 6. So version 6 is where every other thing that will be, so the rest of the version 8, 9, 10, 11, and then the rest. From version 6, it's where they are getting their, like, it's the version 6, it's the, let me say, the spec, the specification that runs every other version. So we're going to move up from version 6 and then come up and then integrate a couple of other versions, cool stuff from other versions of this JavaScript, like ECMAScript or JavaScript, either way. So you can either come see me calling ECMAScript or JavaScript, it still work, right? It still works. Now, moving back to this place. So how does how does how does the browser interpret, how does the V8 engine interpret JavaScript, right? So for us to move on that aspect, so we have to understand another core function, another core aspect, which is how to run your code, right? How does your code get executed, right? How do your code get executed? So I think I'm trying to copy a headline, so I'll just copy this one up and then drag it to this place. And that comes us to how does code work? How does your code work, right? For us to understand how your code basically work, we need to understand compiler and interpreter. Hmm? Browser, um, right? I hope I'm spelling it correctly. I think is okay. I don't know if I'm getting correct. Browser, um, run your code, run your code. Okay. So now that's going to take us to the topic and the final topic here. This is the last time I'm going to explain and then we call it a day. So we need to understand compiler. Then we need to understand interpreter. So we need to understand these core concepts, compiler and interpreter. So what's a compiler basically, and what's an interpreter? Now compiler and interpreter are two methods, right? That the system uses to convert your code to binary. Basically, we have um every programming language falls into a couple of categories. First, we have low level language, we have high level language, right? Now on the high level language, you can find it's also the structure to a couple of other subcategories. We have scripting, we have structural, we have object programming language, object oriented programming language, under high level, right? Same way on the low level. So the low level are basically assembly and binary, right? Now what happens? Now the computer basically doesn't understand whatever I'm writing here. Even if this is a code, the computer doesn't understand it. So the computer has to find a way to convert all of this whole stuff to what's it called, zeros and one. Now we have two methods, right? We have what we called compiler and an interpreter. So how does it work? Now the way the name sounds, that's how it works. Compile. So when they ask you to compile a record, it means that you have to get the whole record together and submit. And when they ask you, for example, if I tell you to compile the names of everybody in this class, for example, now what happens is that you are going to go to every one of them, every person in the class, or you can just say, please drop everybody in this on this program should drop their names, right? And then once they finish dropping their name, you then submit it to me. That's it, right? That's compiling. So how a compiler works is basically it goes through the whole code first before interpreting it to binary. Now, let's say for example, if a V8 engine, if the Google Chrome engine that interprets the whole code and all of these things, it's a compiler, for example. So what happens is that before it starts telling you that there's error in line 20, there's error in line 9, or there's error in line 10 in your project, it will definitely from line 0 to line whatever that your code, let's say it's 20 lines, it will finish going through the whole code before telling you there's an error, and then it will stop there, and then probably tell you this is the error, this is the other error, this is the other error, this is the error that we have that you have, right? That's interpretation, that's compiling. That's how a compiler works, right? So a compiler goes through the whole code and then converts it at once to binary, and then gives it to the system to be able to interpret and then make sense of whatever you have, right? Now an interpreter works like a compiler, but here is what happens. Now if you've watched I don't know, some of these churches, like let's say Deeper Life program, or a couple of these in sign language, yeah. So if you've watched news, I think NTA do sometimes do sign language, I don't know. So you see that when the newscaster, sorry, is saying something, let's say the Nigerian government is going to increase the salary of its workers, then the sign language guy interprets exactly what it said before moving to the next line to interpret what the news presenter said next, right? So the interpreter, instead of going through the whole code once, interpreter goes through the code line by line and then stops whenever it finds an error. I don't know if this is making sense. Now an interpreter goes through the code line by line, evaluating each line, making sense of each line, and then let's say for example we have 10 lines of code, right? Let's say we have let's take this for example as okay, let me leave it here, let me copy this, bring it here, right? Let's say you have 10 lines of code. You have line 1, this is line 2, this is line 3. For an interpreter, for an engine that uses an interpreter as you come with for converting from human language to binary, what happens is that it goes through HTML, this line 1, make sense of whatever is in line 1, interpret it to binary, go back to line 2, make sense of whatever is there, and then interpret it to binary, then go to line 3 till it finishes, right? Now what happens here is that if it finds out that line 1 is okay, but there's an error in line 2, right, but line 3 is okay, let's say for example in a scenario where let's say for example in a scenario good not showing. Let me, I think it's on white. Oh, I don't know why it's not showing. I was trying to get that emoji. So let's say, for example, I don't know how to okay, let me use this as good. Let's say this one is good. I'm using this symbol to represent good, right? So I don't like, I'm trying to show my the emoji, but the emoji is not working for some reason, so I don't want to really stress it out. So now, and this one is good, but there's an error here, so we use X here. There's an error, so we paint this red. So this is red. Let's give this one green. This is green, and this is green. Okay, right? So now line 1 and line 2 are good, but line 1 and line 3 are good, but line 3 has an error, right? What happens is that basically it's going to, after running line 1 and then, okay, line 1 is good, there's an error in line 3, it will stop at line 2. Line 2 is wrong. It's going to stop at line 2 and then point out and tell you line 2 is wrong. Go and fix line 2. And then after fixing line 2 and then it's correct, it's going to then like now when you are done correcting line 2, then it will start processing line 3. And if, for example, let's say, for example, and in a scenario where line 2 and this one is correct, line 2 and line 3 is correct, but line 1 is wrong. So what happens is that it's not going to run. So it's going to stop at line 1 and tell you to go and fix line 1 first before allowing you to go to line 2 and line 3. That's interpreter. That's how interpreter works. So using this, the JavaScript uses an interpreter. The V8 engine that runs JavaScript uses an interpreter, right? So I think with this said and done, and with all of this said, I think we've been able to, I don't know, explain this whole concept, right? And I guess we've understood a whole lot of stuff here, right? So this is where we're going to call it a day, right? So I'm going to give your second assignment. The first assignment is to write down 20 different protocols on the internet, their meaning and what they are used for. So you're going to use a Google Drive. You are going to write it on your Google Docs and make it public. So use a Google Docs. Go and search how to write on a Google Docs and make it public, please. Make it public. Make it public. Make it public. I'm going to this evening. I'm going to drop the link on where to submit the assignment, right? And that's assignment number 1. Assignment number 2. Write all of them on the same Google link, on the same Google this thing, on the same sheet. Sorry. I think I'm having code. Sorry. So now on the second one, your assignment, give me 5 protocols, 5 more protocols that are not here. 5 more protocols, 5 more ports that are not here. Then the last, I'm going to send the last one. So 3 assignment, the last one I'm going to send it on the WhatsApp group. So here is where we're going to stop. So if you have your questions, you can drop your questions. Then on Wednesday this week, we are going to start writing code. So after we've said a lot of stuff, now we start writing code. Yeah, we're going to start writing code. We're going to be putting all of these things in practical now, because this is the basic foundation of whatever you're doing. So I didn't want you guys to understand what you want to do before doing what you're doing, right? So this is where I'm going to stop. On peace.